Well, welcome. We're going to be talking about a few things in this video. We're basically focusing on solving systems of equations. So when I give you two equations and you're trying to solve for x and y. Now it's key to know that you can either get a single solution, you can get an infinite number of solutions, or you can get a situation where there's no solution, where the two lines are parallel and they will never meet. In this particular video, I have three sets of equations here, and they all have a single solution. But we're going to solve using substitution first, and then I'm going to kind of give you a heads up on how you would use elimination, and then how you would use graphing. Graphing is straightforward. You just graph the two sets of, you graph the first line, you graph the second line, and you always have to remember to write the equation in the slope-intercept form. What that means is that you solve for y first, and then you plot it into the graph, and then you plot the second graph, and they will intersect at a specific point. That point is the solution to the system of equations. So before you can understand the systems of equations, you need to understand how to solve a basic equation. So for example, in order to graph this line, I need to solve for y. So do you know how to solve for y? If you don't, you want to go back and review how to solve equations. Make sure you master that principle. You also want to make sure you have an understanding of the properties of real numbers. Now, maybe you haven't mastered all of them, but just get familiar with them and understand how they work and how they help us in solving equations. And then it helps to know how to graph one line. I mean, if you're going to be graphing two lines, it helps to know how to graph one line. So those are the key principles that you would need in order to excel in this particular section of mathematics. There's three ways that we're talking about right now. Down the road, you would learn other ways. So let's go ahead and take the first equation. So x minus 2y is equal to negative 8, and 2x plus 5y is equal to 11. If we're going to use substitution, then the best thing to do is to solve for x in this equation, so that x is standing alone. So we say x minus 2y is equal to negative 8. So you add 2y to both sides. So x is equal to negative 8 plus 2y. So because x is equal to negative 8 plus 2y, we take the contents of x and we substitute it back in here. So instead of 2x, we're going to say 2 into negative 8 plus 2y. So notice that x is now negative 8 plus 2y, and then you add the 5y, and that is equal to 11. So all you have to do at this point is use the distributive property, add your like terms, and solve for y. So we want to solve for y. Notice that we don't have two variables. In the original equations, we had x and y. Now we only have y here. So what do? We distribute negative 16, and then here you have plus 4y plus 5y is equal to 11. And minus 16 plus 9y is equal to 11. So minus 16 plus 9y is equal to 11. You add 16 to both sides. So we get 9y is equal to 27. So y is equal to 3 because we divide both sides by 9. We have solved for y, but we don't know what x is. So we take 3, y is equal to 3, and we plug it back in one of our equations. So we have x minus 2 into 3 is equal to negative 8. And so x minus 6 is equal to negative 8. So what is x? You add 6 to both sides. X is equal to minus 2. So x is equal to minus 2. If I decided to solve these systems of equations, the first thing I would do is I would need to solve for y, and then I would need to solve for y in the second equation, and then I'll put it on the graph, and they should intersect at a certain point. So let's go ahead and solve for y in this equation. So we've solved this using substitution. We're going to talk about solving it using graphing. If we're going to graph, we go ahead and solve in the slope-intercept form, which is y is equal to mx plus b. Remember, that's the form you want your equation in so that you can go ahead and plot the values. So you add x to both sides, okay? I'm going to subtract x from both sides, okay? So I've subtracted x from both sides, and so minus 8 minus 2x, minus x. Now I divide both sides by negative 2. So I divide each term by negative 2. So y is equal to 4 plus 1/2 x. Okay? So we've solved for y in the first equation. Now we're going to solve for y in the second equation. And the same thing, you subtract 2x from both sides, so you're going to get 5y is equal to 11 minus 2x. And then you divide by 5. And so y is equal to 11 over 5 minus 2x over 5. Now remember that according to the commutative property of addition, I could rewrite this as y is equal to negative 2x over 5 plus 11 over 5. I hope you know that. That should be straightforward there. So we solve for y in the second equation. Now let me give you a heads up. Sometimes it's better to use one method than the other. Now with substitution, we're done. Straightforward. Graphing, you look at that and you go, this doesn't look pretty. But you could still use graphing. You could use graphing to solve it. So what would you do? Let's take this equation. We'll start at 4. 4 is the y-intercept. And this is also, of course, y is equal to half x plus 4. So 4 is y-intercept. We know that the slope is 1 over 2. So for every time I move up 1, I move over 2 times. And if every time I move down, I would move over back 2 times. And if I go down 1, I move over 2 times again. If I move over down, I go, okay. And you do the same thing here. For every time you move up, you move 2 times. You go up again, you move 2 times, okay? And so you draw the line for that one, okay? Now, if I'm trying to graph the second line, which is negative 2x over 5 plus 11 over 5, what I would do is I would go to 11 over 5, which is approximately, you have 2, so this is where your fraction, understanding of fractions come from. So this is about 2, okay, 2 and 1/5, 2.2, but let's put it right about there. And that's going to affect things. For every time I move down, so now notice that this graph is going to go this way because the slope is negative. So because there's a negative slope, I look at, it says negative 2 and 5. So for every time I move 1, 2, I'm going to move 5 over. Okay? And then if I move up 2, so 1, 2, and then I move 5 over that way. Okay, I'm going to remove this right here. So if I was to draw a line connecting those, okay. Now please, this is not drawn to scale. This is, I just plotted these values. Negative 1 is there, negative 2 is here, and so on and so forth. Negative 3. We're going to have to get a graph board or something, but the idea is I just want you to see that I'm going to graph the 2 sets of points, and I should be getting something about y is equal to 3, x is equal to negative 2. And if you graph this on graph paper, you will in fact be getting things close to that. So you would be getting the exact values. Again, I just sketched this using the tools I have. You can use substitution, you can use graphing, and you can use elimination. The idea with elimination, and I'm just going to use elimination for the second one as we close, is 2x plus 3y is equal to 6, and 2x plus y is equal to negative 2. So I'm going to subtract. Okay, here's the thing. With elimination, you eliminate one variable right away. So I'm going to subtract. So that's going to get rid of the 2x minus 2x. And then 3y minus y would be 2y. 6 minus negative 2 would be 8. So y is equal to 4. Do you notice that elimination is the best way to approach that in a sense? Right away, I'm done with that. And I take y is equal to 4. I substitute it back in. So 2x plus 3 into 4 is equal to 6. And so 2x plus 12 is equal to 6. 2x is equal to negative 6. And x is equal to negative 3. I know I went fast at the end there, but please, this is just giving you the basic steps you need to know how to use substitution, elimination, and graphing. I want to encourage you to look at the textbook you're using, review the examples they've given you, seek to understand the concept, seek to teach other people what you understand, and do not think that you can't do it, okay? You have to put the effort, do your best, email if you have questions, and let's do the best that we can, let's work hard, stay humble, and encourage others to do their best, okay? Have a wonderful day.